last unit in chapter 2. So we'll be dealing with section 2.8, and we're talking about one-to-one functions and inverses. Inverses you'll remember from Algebra 2. One-to-one will be the new concept here. First, let's review inverses. So typically, you're given a function. Y is some function of x, and we're given an x, and we solve for y. Okay, if this is a function, then each x has only one y associated with it. This is the vertical line test. That's basically the vertical line test. Okay. And when you look at this graphically, you might have a function which looks like this. So if I give you this x value, you can come up over here and read off what the function is. Okay, and this is our normal setup. This is the inverse. On this one, you're actually given an f of x. You know the y value. What you have to do is come over here and read off the corresponding x value. And this is the inverse situation. Okay, now when we did inverses in Algebra 2, we basically had three different ways to find inverse of a function. Okay, if your function was given as a graph, then you reflect across y equals x. There's our first one. If the function is given as a table, then you swap the x and y values. Now you can always come through, and if you're given a graph, convert it to a table, and then swap them and then regraph it. It would accomplish the same thing. In part 3 then, if you're given an equation, and this is where we will be working in this course, is on the equations. You switch x and y, then solve for y. Okay, I'm going to have one difference from the book. In your book, they talked about that not all equations have inverses. I view this a little bit differently. All equations have inverses, but the inverse may not be a function. In other words, you might get more than one output for a particular input. And there really is a rather simple example of this. Let's take a look at the parent function of a parabola. All right? Its inverse looks like this. It's a square root function. Okay, this thing is a function. It passes the vertical line test. This thing is not. So remember what happens now was this was our original x and y. But now basically what we've done is flip this thing on its side, which is what it looks like when you rotate around y equals x. And now this was our old y-axis, and this was our old x-axis. So for it now, so if you got an x, you get a y. The problem, though, is when I come down here, I can get two different x values. And these oftentimes are not very useful unless you can eliminate one of the outputs. And this leads us to the next point I want to talk about. So functions and here I've narrowed it down from equations to my original thing I'm dealing with as a function, which means it passes the vertical line test, whose inverses are also functions. Are called one-to-one. Now, as a definition, that's all right. But as a useful tool to tell if something is one-to-one, this really isn't very useful. But basically, all this is saying is that each x and f of x are paired uniquely. And again, try to get a concept of what's going on, this is all right. To actually find it, this is not so very good. So the way to find a one-to-one is, okay, a function is one-to-one if both of the following hold true. Number one, it passes the vertical line test, which if it's a function, so we can actually change this and call it an equation. And number two, it passes the horizontal line test. So you need to pass both the vertical line test and a horizontal line test. So let's take a look again at our parabola. Okay, this thing passes the vertical line test. That's not a problem. However, if you pass a horizontal line to it, you see it hits at 2 points. So this thing passes VLT, fails HLT, so it's not 1, 2, 1. Or another way of saying this is its inverse is not a function. Let's take a look at one that is. Y equals x cubed. Parent function for a cubic. This guy looks like this. Okay. Well, it's going to pass the vertical line test. But even more than that, it's also going to pass a horizontal line test. So this passes vertical line test. It passes a horizontal line test. So y equals x cubed is 1, 2, 1. And its inverse is a function. Okay, so let's look at some examples of what you're going to be doing. So we're going to find inverses from equations. The equation you're given, f of x equals the square root of 2 plus 5x. Okay. So the first thing we're going to do is substitute y for f of x. I'm going to end up with y equals square root of 2 plus 5x. All right, so let's do a different color. Now we're going to switch x and y variables. Just switch the variables, not switch coefficients. So when I do that, I end up with x equals square root of 2 plus 5y. So now we've done that part. Now we need to solve for y. Okay. Well, the first thing I notice I need to, a problem is I have a square root. This is not a problem. I square both sides. This gives me x squared equals, the square of the square root cancels it out. So I get 2 plus 5y. Now I solve for that. I'm going to use symmetry, move my 5y over. No, I won't do that yet. Let's do this. So I'm going to subtract my 2. I end up with x squared minus 2 equals 5y. And I can switch sides on these now. And then I divide by 5. So y is going to equal to x minus 2 over 5. Should be x squared. Forgot my squared. So x squared minus 2 over 5. Okay, and then one more thing we're going to do, and we're done here. Because this is an inverse function, we're going to denote it a little bit differently. So now we're going to come back in and substitute and this right here tells us we're dealing with an inverse. It's f negative 1 for y. So now I'm going to have f negative 1 of x equals x squared minus 2 over 5. And that is the inverse of our original function. Let's do another example. This one looks really bad, but it's really not. So we've got f of x equals 1 plus 3x over 5 minus 2x. So the first thing I want to do is switch f of x for y. I'm going to have y equals 1 plus 3x over 5 minus 2x. Okay, my next step then is to swap x and y variables. And everywhere I've got an x, I'm going to put a y, and everywhere I got a y, I'm going to put an x. That gives me x equals 1 plus 3y over 5 minus 2y. And at this point, everyone's looking and thinking, okay, you got 2 y's and you got a fraction. So now we're going to solve for y. And the first thing I'm going to do is get rid of the fraction, which means I'm going to multiply both sides by my denominator. So I'm going to have x times 5 minus 2y equals 1 plus 3y. This is a pretty typical technique. Okay. Now I'm going to distribute my x in. So I've got 5x minus 2xy equals 1 plus 3y. Okay, so the next thing I'm going to do once I get this is put all terms with y on left side. Okay, well this one's already here. So what I'm going to need to do is subtract 5x from here. I need to move this over, so I'm also going to subtract 3y. That's going to give me a negative 2xy minus 3y equals 1 minus 5x. Okay, now I'm going to factor out my y term. That way I can solve for it. I've got a y in both of these. So I'm going to do y, and then I'm going to have negative 2x minus 3 is going to equal to 1 minus 5x. Okay, well, now at this point all I have to do is divide by negative 2x minus 3. So now I'm left with y equals, I got 1 minus 5x over negative 2x minus 3. And then my last thing then is to do the inverse. And you're done.